I don't know how can I fix this because this is just the first time. Also, I found that in the previous streaming, the recording of the audios during the previous one discussed what is the particle physics. So we discussed that there are some elementary particle. There are three different types: neutrino, charged lepton, and the quark. And they have the different type of the charge, like the color charge, electric charge, and the weak charge. And depending on the charge, they can participate in interactions by exchanges through Rolls carrier, as a gluon, double dot boson, and there are some probability, some of the wisdom of the quantum field theory. I will use the perturbation theory, and in each order of the level, there's a corresponding Bellman diagram, and we can compute some amplitude from the diagram. And I don't know why there's compute some amplitude from the diagram. This one. And I don't know why there's still howling, so I just removes the sound here. Okay. Now I'll talk about some today's topic. So today I will talk about the quantum field theory. So already I mentioned in the previous video, the quantum field theory is the combination of the special relativity theory and the quantum mechanics. And the goal of the quantum field theory is the obtained amplitude, probability of amplitude, from the initial state to the final state. And this can be obtained from the Bellman diagram. So, such as the amplitudes defines as some inner products of the binary state and the initial state, which is from the cat boxes and the quantum mechanics. And we can expand this sort of this initial and the binary states with the order-wise order. So actually there are some time evolutions of light in here, where the U is the time evolution. So there are some initial state is prepares, and it evolves through with the time evolution of prices, and eventually it reaches the binary state. And such a time evolution of light is described by the exponents of the IHT, where H is the Hamiltonian. This is some of the languages of the quantum mechanics. And we can expand this sort of the field theory language, so the Hamiltonian is replaced by the Lagrangian, which is integration over the space-time. So there are interaction Lagrangians in here. So we can expand this exponential order-wise order, then the amplitude in the product and binary and the initial state is given by the order-wise order. So if the interaction Lagrangian contains some of the coupling Z with some field pi or psi something, then there might be some order expansion due to the zeroth order, due to the 1th order, due to the squares, and due to the cube, and due to the quadratic, and we can go on, and by that we can obtain the Bellman diagram. So there are two types of some of the components of the Bellman diagram. The one is the external field, which corresponds to the external line, and the one is internal line or internal field. So there are external line and internal line, and the external lines correspond to the some propagators, not propagator. Maybe the internal lines correspond to the propagator, and external lines correspond to the external field, and this can be obtained by the contraction of some on-shell particle field and some internal field. And the internal lines are coming from the contractions of the internal field, several internal field. So the contraction means that the contractions appears when we reorganize of the order of the field. So initially the fields are ordered with the time ordering to satisfy the causality of the special relativity theory, and we can reorganize with the normal ordering. So there are some the modeling mean that the creation operators go to the lab and the annihilation operator go to the light, and so that each operator can gives the zeros when it acts in the vacuum. So the vacuum expectation of the values with the normal ordered build of latest, and it can give the value of the zero. So there is some benefit. It has a benefit to compute something easily. So we reorganize from the time ordering to the modeling, and there will be some remaining term. It's called the contraction. And this contraction is correspond to the propagator, which is some of the endpoint correlation functions, 2-point correlation functions, which is some of the some of the two builds of n builds of operators are action on the inner state to the final state, and it gives us some how the builds are propagate from the some specific point to the other point. So that this propagator is actually correspond to the green functions of the equational motion for the Greek field. So that I think that are some of the very hard things here, but I just want to just keep going on. So that there are two types of the pure external fields and propagated. And there are one more thing, vertex, and the corresponding vertex there will be some of the coupling, which is part of the interaction Lagrangians. So there are three components. One is the external line, and the second is the internal line, and the third is the vertex. This and the time. So you can find that there are electrons, and some of the quark is an electron in here, and Q is a quark. So they are some example of the external line in the external build of this diagram. So they're coming from the infinity path and infinite future. So they are external build, and sometimes it is called the on-shell particle. So that we can observe that it is electron and quark. So initially such electron and quark as a prepared exist, and also binary they also exist. But the case of the photon, whereas gamma in here, this is an off-shell particle, so the internal fields or off-shell particle. So they are some of the virtual particle. They produce this at some moment, but they are analyzed, destroyed. So that they are just they just exist in some of the moment, not permanently. So it means the optional particles. So corresponding to this internal build, we should give some of the propagators components for the propagated contributions to the amplitude, and for correspond to the external build, it contributes to the external build. But depending on the types of the build, if the particle does spin 0 or spin 1/2, spin 1, then they give different types of the contribution. For example, if the propagators for propagated contribution to the amplitude, if the particle is correspond to the spin 0, then the propagator forms are given by the I over the q square minus m square, where the q is the momentum transfer, which is momentum changes, and m is the mass of this spin 0 particle. But if the particle does spin 1, then the propagated form is quite different. This is given by I g mu nu, and let's assume that there are spins 1 and that this particle is massless. Maybe if this is massive, then there are additional terms like as q mu, q nu over the m squares, I remember, and there are q squares minus m squares. Is complicated form, and there are mu nu index coming from the because it is propagated coming from the contractions of a mu and a nu with the expectation value. So that this mu nu index gives us such a space-time indices for the propagators. And for example, spin 1/2, the propagators forms are more difficult, more complicated. So the propagators are given by the I. Gamma mu p mu, there are contraction for them, and the p plus m, and the gamma there are p squares minus m squares. This p is also same for the moment transfer, so I want to return the q. So that the point is that depending on the spins of the particle, the form of the propagator is different. Also, it is the same for the external build. So if the particle does spin 0, then there are no contribution that gives just times of the 1. But for the spin 1/2, it gives us some of the spinor solution. U or V. So the U is the correspond to the sum of the particle, and the V is the correspond to the antiparticle, and also there are also U bar, which is outgoing particle. So the U is the correspond to the ingoing particle, and also there are V bar, and for the antiparticle case, the V bar is the ingoing particle, and V is the outgoing antiparticle. And for spin 1, there are some of the epsilon mu, which is some of the gauge boson solution. So spin 1 particle solution is called also is called a polarization lattice. And depending on the ongoing outgoing, so that there are epsilon mu and epsilon mu star. So the point is depending on the particle and this particle is ingoing or outgoing, the form of the external fields are also different. So that there are external fields and propagate. And one more thing, there are some of the vortex. We found that we can observe that there are some of the meeting of the line, so that there are electrons minus and electron plus positrons, and the gammas that missed in this vortex here. So there are some of the corresponding Lagrangians. So if we like each field, so for example for the electron, let's assume that the electrons are denoted as a psi. This is the spin 1 half particle, and such photons are denoted as a mu. This is spin 1 particle. And in this case, the interaction Lagrangians are written by the psi bar and the gamma mu, a mu, and psi. I will explain why the such a form is important. So the point is that there are three particles here. There are psi, bar, and the a mu, and the psi. Here the G is the coupling here, and this 2 is the field, so the sum of the particle, and there are one more some of the gamma mu, some of the more quantity. This corresponds to the gamma matrix to make the Lorentz invariance here. I'll explain what it is in the future. But the point is that this interaction Lagrangian, it contains three fields with the coupling. So there are the psi bar, one thing, and a mu, one thing, and psi, final one. So there are three fields, and from this interacting Lagrangian, we can obtain this of how the particles interact. So it gives three fields meeting in here. So the one spin 1 photons and two spin 1 half electrons are meet here. So in the Bellman diagram we can observe that there are two electrons are meet with one photon. This interaction strength is determined by this coupling. So if the coupling is very large, then the interaction is very large. So this is interaction strength. So in the previous time we discussed that there are some three types of interaction: weak interactions, and the electromagnetic interactions, and the strong interaction. And in the case of the strong interaction, the coupling is very large, so the strength of the interaction is very large. But in the case of the weak interaction, it is difficult. Actually, the weak interaction coupling is very large compared with electromagnetic interaction. But in this case, there are some effectability regimes applied, whereas in the low energy regime, compared with the WZ boson mass, actually WZ boson has a massive, so I will explain the electroweak theory chapters in the future. But the point is that in the Fermi theory, with the low energy regime, even though the weak interaction coupling is very large, the effective coupling is very small, so with the Fermi constant, I will explain in the future. So the point is, now I will return to our point. We can draw the Bellman diagram like this example, and we can obtain the amplitude. So there are three components of the Bellman diagram. One is the external line, and the second is the internal line, and the final one is the vortex. And the correspond to this Bellman diagram, we can give each contribution. External line gives the external field contribution, and the internal line gives the propagators, and the vortex gives the coupling. So this is the points of the quantum field theory, and maybe I will give some of the specific example. So maybe I will give some example of the QED. Already I discussed QED interactions. QED some scattering. So Bioman diagram QED amplitude. I hope the propagated, and some vertex gives the coupling, and also external line gives us some of the amplitude. Maybe the good examples are also here. External line gives the external build, the vertex gives the coupling, internal line gives the propagator, and yeah, maybe the I bound. This one is a very good example. So they draw the Bioman diagram here, and the corresponding to the its red lines correspond to this external build, and the external build gives the such a spinner's contribution. So for example, the U1, this is an ingoing particle. The time directions from the down to the up, so that it gives a U1, and that is U1 was outgoing particle, so that it gives this contribution. And there are propagators, which is a photon, and this is a mass loss. So the propagator for the mass loss spin 1 particles are things like that, and the U2 and U2 bar, there are ingoing particle and outgoing particle, and the vortex IE, IES, and there are gamma matrix multiply. So if we multiply all the contributions from the Bioman diagram, we can obtain the probability amplitude. So now we can obtain the probability amplitude. It is sometimes written by the Maskell. This is actually the inner product of the Bioman initial state, and we use not just m, and the probability is actually the scalar of this amplitude. So the scalar of this amplitude, and this is a complex number, so we should absolute value magnitude of the m, and actually the process of the some process that occurs with this probability, but we want to obtain some of the decay light or cross sections. The decay lights correspond to the one of the lifetime. So if the decay light is very small, then the lifetime is very long. And the cross section is the correspond to the area, effective area. So if the cross section is very large, then effective interaction area is very large. And this decay light and the cross section can be obtained by the integrations of this probability amplitude over the Lorentz invariance phase space. This is a phase space, which is correspond to the sum of the D4P. Something. This is a spatial relativity regime, so that we should use some of the unified space-time. So we can assign the decay light on a cross section, and it might be a function of something. So for example, the decay light is a function of the energy of the some binary particle something, or the cross section is also can be functions of the some energy or the some of the angle. So we can plot the decay light and the cross sections with the x and the y axis, so then we can check the some comparison between the theory and some of the experiment result. So we can multiply that deal with for example, the QED interaction Lagrangians, and we can find that there are some of the problems of anomalies in here, and we can fix the theory. But this is a contemporary theory. So the point is that there are Bioman diagram, and we can obtain the amplitude from the initial to the final state, and we can obtain the real observable. Real observable means that this decay light or the cross section. So this is some regime of the contemporary theory, and there are some of the technique to obtain the amplitude. There are some of the internal line, external line, and some of the vortex thing. And to do that, we should know some of the terminology of the propagators, and actually this comes from the and correlate the functions of the several build. So this is level. We define the builds first, and we can bind the propagators with some endpoint correlation function, and from that we can obtain the internal, external, and the vortex contribution in the Bioman diagram, and we can obtain the amplitude, and we can bind the observable like the decay light and cross section by the integrations over the Lorentz invariance space. So I think maybe this I spent sort of this 20 minutes. Then now I want to talk about some non-academic things. So I already talk about some academic thing, and already I mentioned that maybe next time I'll talk about the normalization, and also next time also I'll talk about the many types of spin, one half spin 0 and spin 1, and also I'll talk about the standard model Lagrangian. And now we'll go to the BSM, like the neutrino, dark matter, and supersymmetry, and I will go to the some of the cosmology. And finally, I will go to the research, my research paper. So now I want to talk about some of the non-academic thing. So there's some academic thing, and maybe I can obtain some non-academic topics here. So first of all, I want to talk about some of the acquisition life. And other things, how can I live? There are two within the first of my life. This is the point of sort of the loan. So how can I spend sort of my time, and how can I live very well? And the second thing is how can I give some good relationships with other people? Relationship with others. So there are 2 points of view, and maybe okay, I think that there are 4 important areas. So there are the first one is the question life, and the second one is my life. How can I spend the time on my life or hobby or something. Maybe there are some like my healthy such thing, and the third one is the relationship. How can I make the story with the other people, some of the conversation, or some of the meeting with many people, like the group meeting, or some of the how can I manage my brand relationship, or some of the romance thing, etc. And okay, I already said about the academic. That's my work or research. So maybe the first of all, in this 4 point of view, I will talk about the various topics. First of all, already I went to the church in this morning. So in every Saturday morning, I go to the church with the group meeting in the leadership of my church, and maybe there are just 2 group meetings are remain in this term. So coming the final weeks of July, there will be some of the final group meetings, and in the next month there will be no meetings. So maybe there's just 2 meetings are remain for the Saturday, and already we finished some one book, which is which we lead and discuss together in the every Saturday meeting. So today we discuss the Song of the Song, and today's topic is some of the love and the romance thing, some of the point of the question. And I cannot remember all the things, but the one thing is we share some of the our own things, like as our time, share sort of our things, time or our energy, or our work or our career. If someone has someone becomes a couple, and if they get married, and they sometimes give up something, and maybe they will share their things, and this is also similar to the love between the God and the Christian. And the second thing, maybe I remember the thing. Maybe there are some definition or concepts of the beauty. So in the Song of the Song, there are many description of the how the body and some of they describe some of the body in their romance, and in the points of the creations, our bodies are created by the God, and there's beauty in the point of the gods. But in the points of this modern age, they sometimes sometimes focus too much in their bodies and all their base, and it might be a problem. But sometimes we should also manage our body and our base more clear, so there will be some harmonic point, some of the equilibrium point between them. And maybe the third thing, okay, maybe I can't remember. And maybe we can share this concept thing, but maybe in the tomorrow's meeting, in the Sunday meeting, maybe I will discuss about the personal preference of the lover, or preference of the girl and boyfriend. I don't know the proper word. Maybe we will share the band. Maybe the important tomorrow's topics that we'll visit our one members in our group. So the visiting the house of the one member, and maybe she will give us some good food for us. So that was what happens to it. And after that, in this lunch, we discussed. We just eating the lunch together, and we shared many things in our life. Especially there are some of the many people are in the same campus, and they studies in the mathematics or electronic device thing. So we just talk about the our life of the studying or researching something or future plan, like as going to the university, and there's some problems sort of that they are studying, like as they glide, and we just talk about it, and maybe I think that's a good time. And so I this just I just realized that I should not get the topics of the order. So sometimes someone talk about the talk something, and I just listen about it. And if there are some of the common things, then the common things for me, then I just talk about my story. But I think I do not. I should not. I don't know the proper word. I should not take or get. Maybe someone want to talk about their story. Not they don't want to listen about my story. So maybe I should maintain the original topic rather than me. So I think about this once in this many time. So that's what happens. So that's a relationship thing. And one thing I want to mention that I subscribed to Netflix today. I think in the previous day, in the past, I think it's such a some cultural thing is a very bad thing for me. But nowadays, I think about the spending of the time more effectively is a one way to live very well. So I subscribed to Netflix, but I found that some of the US dramas are not in here. For example, the Big Bang Theory. That I cannot find it in Netflix. Maybe there is in the Watcher. But a lot is subscribed on Netflix, so I will see some of the Korean dramas first. And also, maybe I want to see some of Japanese drama, some of the animation. Because in this day, I just studied about the Japanese in myself. So almost 5 years ago, I took about 5 years ago. I studied about the Japanese in there on the level when I was in the university, and but I almost forgot because of COVID-19 occurs in the 2020. This 2019, and now I realize that almost 5 years is passing through. So I returned to this city, the January 2022, and there are some 3 years ago. And these 3 years are correspond to the graduate school with the research on the neutrino or supersymmetry. Also, I studied myself about the quantum field theory and the cosmology, and also there are some of the new church for me in my life. Actually, I go to the church in with my parents in the same church almost 70 or 20 years, and such a new church is quite building, it gives a quite new building to me. So there are some different types of the Google meeting and different types of voices, and many different people I can meet, and that there are thoughts and ideas that quite different. So that there's a very good impact for me, and quite new things. So also my lifestyle quite changes. Now I had another financial independence. Financial independence. Maybe independent in the, because I started on the money. And there was my house, not actually not my house. I just lent some of the one house. Actually, this is just a one room. And now I should eating myself, and some of the laundry myself, and also buying the nursery, some observing, and something. There are some of my lifestyle eventually changes. So the maybe I think there are some of the very turning point, or some of the many changing moments of this day, but I don't know I can go to the some of the more good way, but so I'm trying the new thing is a very good thing, I think. So the actually I read it in the 1 or 2 years ago. I read it started of the YouTube channel with the starting of the handwriting, handwriting physics. Actually, at that time, I want to learn myself, and actually there's a no more some of the course I already graduate. So the I don't have no plan. How can I keep maintain my studying, and maybe I explain my studies to the other ones. Then I should prepare some more details, so that it makes my studies more strictly. So that maybe this is helpful. So that I started a YouTube channel 1 or 2 years ago, and 2 years ago also there are blogs of the book review. And now that I start sort of but also the think about myself. So I think it's a very good way. Okay, there are some of the advertisement here. I will remove this. Actually, this English diary is started in the 5 years ago. English diary. But I didn't share that this English diary videos with other ones. So I hope that there is a very this English is very work very well, and maybe this just remaining time I will call to my friends and eating dinner together if he have time, so that I will just go into calling teams, and maybe I think that's almost I spent about 34 minutes rather than the more than the yesterday. So I hope the good evening time in tonight, and also the good time for the tomorrow, and good time for the coming week, next week. I hope that I should do some of the academic thing, like reading of the paper, studying myself of the new thing, or partially the doing of the projects. I have those 2 meetings in each week, and 2 meetings for some of the one of my projects, and I should work through something and bring some of the new result, but I don't know how can I do this. And yeah, maybe also I think about some of the new idea and the new topics in our my research projects in the future. Maybe I should make some of the physics plan. So I think that's